Hello friends, welcome to Physics with Ben. Don't forget to subscribe, like, comment and share this video. I want to use this medium to thank you all for having confidence and faith in me. Our channel have grown to 2,000 and above subscribers. Thank you. We shall get to 1 million and even 1 billion someday. In today's video, I want us to look at a brand new topic: costs of electrical energy. And these are the questions I would like us to solve as we look at this topic. First up, what we are supposed to know before we solve these questions are some basic terminologies used and also the equations and how to apply them. If you remember, I made a video on current electricity. In that video, I solved some questions and I also talked about the electrical work done, the electrical energy, the electrical power. You may love to click in the description on this video you are watching to watch all those video series. Learning is always from known to unknown. If you don't understand the other concepts, you won't understand how to calculate the cost of electricity. Before we proceed, what are the learning objectives of this topic? The cost of electricity. There is a reason why we are studying this topic. Number one, to know the terminologies and standard units used in calculating electric tariff universally. It means that everything you are learning in this video you are watching is universal. The SI units, the equations can be used in any part of the world. The only difference is just the currency. Number two, use all of Ohm's law equations to generate all the equations used in calculating the costs of electricity. Number three, explain what kilowatts and 1 kilowatt hour are. Know all the hidden facts in calculating the costs of electricity. Practically calculate the costs of electricity in any country you find yourself. When you know this, you will not be cheated. And lastly, you are supposed to apply the knowledge in this course, the cost of electricity, to stop wastage of electrical power and energy at home, school, and working places. I want to throw more light on these objectives. There are moments you see people, you are not at home, you just leave the bulb on for hours. Some people will just on their radio set, be running for hours. You have an apartment or a home with 100 bulbs, and people wake up, they go for work and they don't turn off the lights. They go, and before you know, the NEPA or the power holding company will bring the tariff, and the tariff will be very, very high. So the knowledge of this topic will help us reduce electrical bill, so that when the month is ended and we are to pay bills, we will not be paying too much money on electrical tariff. This is the usefulness of this knowledge. You will know that, oh, for you to leave this bulb on for these hours, there is something that is happening which you have known in this topic. And of course, as a student watching this video, you now know why mom and dad will tell you
turn off the lights when you are not using it.
So without wasting more time, let us go straight to the business of the day. Recall. Recall that electrical work done, the electrical work done, or electrical energy, the electrical work done is given to be Q times V. And this electrical work done is the same thing as the electrical energy. The electrical work done, the work done in moving a positive unit charge from terminal A to terminal B to a conducting material. So that electrical work done is given as the quantity of charge times the potential difference. And this is measured in the units of joules. Now, you can also remember in our topic work done, work, energy, and power that power is defined as work done all over time. But since we are talking about electrical work done or the electrical power, we are going to use the work done in current electricity. You know that ordinarily work done is defined as force times distance. But we are not going to make use of this particular equation here. We're going to make use of this equation. So we define the electrical power P as Q times V all over T. You may call this your equation number one. This electrical power can also be defined as, let me rewrite this. Since work done and electrical energy have the same SI units, we are free to say that electrical power is equal to electrical energy all over time. And this, you call this your equation number one A, equation number one B. So we are going to concentrate on equation number one B because equation number one B relates to what we are doing here. So the electrical power P, from this equation number one, we also have that the electrical energy is given to be the power P times time. We call this our equation number 1C. Yeah, we call this equation number 2. Equation number 2. I want to concentrate on equation number 1B and equation number 2. You recall that the electrical power, the electrical power P is defined as the rate at which work is done in moving a positive unit charge from one point to another with time. So the rate at which current flows through a conducting material per unit time is what we call the electrical power, and that is given as energy all over time. And so from here we have energy is equal to power times time, and the units for the electrical power is given as watts. It's given as watts in symbol capital W. Now the unit for electrical energy is the joules. Capital J is a unit. Good. Now, having known this, in this topic, there are three things you need to know. These are the two main equations we are going to use for now. I'm going to introduce the next equation, but we're going to look at this before I introduce the third equation we are going to use throughout calculating questions in this topic. You need to know that in this topic, we don't actually make use of watts. We make use of kilowatts. And then the examiners may ask you, what do you mean by kilowatt hour? What do you mean by kilowatts? So we make use of kilowatt. And when we say kilowatt, 1 kilowatt is the same thing as 1,000 watts. These are the facts that you need to know. The other one is 1 kilowatt hour. What do you mean by 1 kilowatt hour?
1 kilowatt hour is defined as the rate of working of 1,000 watts for 1 hour. It is also the standard SI unit for the electrical energy consumed by electrical appliances. It is the unit used in calculating electrical tariff.
These are the stuff we are going to use in this equation. So from here, from equation number 2, we have our E is given to be power. We say the power we make use of here is a kilowatt, right? So say power, dimensionally we'll have kilowatts times time. Now the next thing you need to know is that if you are given a question to solve in this topic, the time, be it in minutes, be it in seconds, be it in days, you must convert the time to hour. The time must be in hour, the power must be in kilowatts, the power must be in kilowatts, the time must be in hour, the power must be in kilowatts. That is what you need to know. So the time here is hour, and if you multiply the two, you're going to have kilowatts hour. And we write it this way: lowercase k, uppercase W, and lowercase h. That is how it is written. So I want to introduce the last equation that we are going to use, and then we will proceed in doing our calculation. And don't also forget that every equation you have learnt in Ohm's law is applied while solving this question. You can agree with me that from here we may do some cut and join, where you know that V is equals to IR, and you can also substitute it here and make and form some complex equation. So now, what is the equation that is used in calculating the electrical energy? The equation is simply given as cost of electricity is equals to rate, the rate at which the electric current is sold, times the energy. This equation is very, very important and fundamental. So we write that the cost of electricity is given to be the rate at which the electric current is sold times the energy. So we call this our equation number 3. So we want to clean up this and rewrite these 3 equations somewhere, because we are going to make use of them throughout these calculations. So I will rewrite them up here. We have our equation P, the power P, to be E all over T. We also have our energy E to be equal to power P times time. This is equation number 1 right now. This is equation number 2. And then we'll have cost of electricity is equal to rate times energy So I will clean up this stuff here. And another equation that we are going to be using here throughout is you also know that your V, your power P is equals to QV all over T. Yes, and your V is equals to IR. All of these equations, we are going to make use of them in this calculation. So let us get straight to the business of the day. We want to solve question number 1. Solution to question number 1. Good. Now, if you have been following my videos, there is something I always say when I'm doing calculations in physics. I talk about the 5 C's of calculations. I call it the algorithm of calculations in physics. The 5 C's are correct data collection, correct equation, correct substitution, correct evaluation, and correct answer with SI units, if any. So we are going to collect our data. So let's read the question. A lamp marked 1000 watts, 250 volts is lit for 10 hours. If it operates normally and 1 kilowatt hour of electrical energy costs 2 kobo, what is the cost of lighting the lamp? So the first things first we are going to do here is to generate our data. So number 1, our power P is given to be 1000 watts. 1000 watts. And you know that we don't make use of watts in this equation. So you must convert watts to kilowatts. So this is the same thing as 1000 divide watts divided by 1000. And this will give us 1 kilowatts. So this is the unit we are going to use concerning the power P. And then the next thing is the voltage. The voltage V is given to be 250 volts. So it is lit. The time T is given to be 10 hours. Good. And then the rate RAT is given to be 2 kobo per 1 kilowatt hour. That is the rate. And then the next thing is the cost. The cost is not given. The cost of electricity is not given. So what we have to do here is to find the energy. The equation for cost is equals to rate times electrical energy. So let us find what our energy is. For this equation, our energy is given to be power times time. So we write that our energy is equals to power P times time. So if we substitute correctly, we are going to have our energy is equals to power is 1 kilowatts. So write that 1 kilowatts times 10 hours. So 1 kilowatt times 10 hours, we're going to have 10 kilowatts hour. That is our energy. So therefore our energy is equals to this. So the next thing we are going to do is to calculate the cost of running this lamp. So our cost is equals to rate times energy. Good. So our rate is what? Our rate is giving us 2 kobo per 1 kilowatt-hour. Our energy is 10 kilowatt-hour. So this kilowatt-hour, we cancel out this kilowatt-hour, and then you are left with 2 times 10. That will give us 20 kobo. 20 kobo is our final answer. Therefore, the cost of running this electricity, the cost of running that lamp marks that for 10 hours is 20 kobo. So if you are in the US, I told us from the beginning that this equation is a universal equation. This is the place you put in your currency. You can say that the cost is $2, 3 cents, and then put that here. That is how you go about it. So we are done calculating question number 1. So the question number 1, our cost, our answer is 20 kobo. 20 kobo. That is the answer. So I'm going to clean up this so that we go for question number 2. Good. Question number 2 reads, an electric iron rated 250 volts has a coil of resistance 120 ohm. What is the cost of energy for pressing this iron? We collect our data. So we have our volts is given to be 250 volts, and resistance R is given to be 125 ohm, and the cost what is the cost of pressing the energy? It's like this question has issues. Let me verify the question quickly. Something is missing in that question. An electric iron. Good. What is the cost of using? What is the cost of pressing it for 1 hour? Yes, for 1 hour. Sorry. Cost of pressing. Yeah. Cost of pressing for 1 hour. What is the cost of pressing for 1 hour at 10 kobo? At 10 kobo. At 10 kobo per kilowatt-hour. You see, I told us the question has issues, and that is the problem behind the question. So our time T is 1 hour, and the rate of running, of selling that electric current per 1 kilowatt-hour is 10 kobo. 10 kobo per 1 kilowatt-hour. So if you observe very well in this question, V is equals to IR. These are the basic equations we are going to be using all throughout this calculation. Power P is not given. Energy is also not given. And cost is also not given. I always tell us that physics questions are like bone and marrow question. You have to break the bone before you get to the marrow. So we have to find the power. So what is the equation in finding power? Our data is collected. Recall that power P is equals to power P is equals to IV. Yeah. From here, you know that power is equals to QV all over T. And you know that Q is equals to IT. So you know that this is same as ITV all over T. This go, and you have IV. Good. You know that from P is equals to IV, you know that from Ohm's law, this is equals to IR. We are not given the currents here, so we are going to change this. So you know that from here your I is equals to V all over R. So this is the same thing as V all over R times V. So that our power P is V squared all over R. This is what we are going to use. And if you evaluate that correctly, our V is given to be 250. You square it. Your R is given as 125. If you do that correctly, you are going to have this 250 squared divide by 125. 125. That will give us 500 watts. But we are not going to use watts. We will have to convert this to kilowatts. So we say that 500 watts divided by 1000. This go. Sorry. This go. You have 5 all over 10. Yeah. 5 here 1, 5 here 2. So you have 1 all over 2. And that is 0.5, right? Good. Let me verify my answer. 5 divided by... Yep, I was correct. So your power P is 0.5 kilowatts. This is what we are going to use. So now that we have gotten our power P, we can now find our energy because our time is given to be 1 hour. So our energy is given to be power in kilowatts times time in hour. So we write that our power 0.5 kilowatts times 1 hour, and that will give us 0.5 kilowatts hour. So our energy is given as 0.5 kilowatts hour. Don't forget, always write it lowercase k, uppercase W, and lowercase h. So at this point, we can now put in our cost. Cost of the electricity is given as rate times energy. So our rate is given to be 10 kobo per 1 kilowatts hour. Our energy is 0.5 kilowatts hour. So kilowatts hour will cancel out kilowatts hour. And so you're left with 10 kobo times 1 over 2. that will give you 5 kobo. So you have cost of electricity is 10 times 0.5, that will give you 5 kobo. Yes, I was correct. So the cost of running this electricity is simply what? 5 kobo. The cost of running this electricity for 1 hour, pressing this iron for 1 hour by that man is 5 kobo. I would love to clean this. Good. The next question we want to solve, we are done with this. Question number 3. What is the cost of running 5 watt lamps and 4 100 watt lamps for 10 hours if electrical energy costs 2 kobo per kilowatt hour? As usual, we are going to collect our data. Our power P, we have 5 this. So we're going to write total power. We have different powers here. We have this power, we have this power. So we're going to find summation of the power, the sum of the powers. So the first power, the total power in the whole arrangement, the first one is 5. 5 times 50 watts divided by 1000 plus, we're done with this. This is already in watts. 5 times 50 in watts, and then divide by 1000 in kilowatts. Then we have lamps. Then for this, the right plus brackets 4 times 100 watts divide by 1000. What next? That is that. We put the answer there. So for the time t, the time is 10 hours. The time is already in its standard units, so there's no point to convert the time. I told us that if the time is in seconds, in years, in days, in minutes, you must convert the time to hours. Good. So the next thing on the line is the cost. Sorry, the rate. The rate is equals to 2 kobo. 2 kobo per kilowatt hour. So they want us to calculate the cost. The cost is not given, and then the energy also is not given. So let's work this out quickly. We have 5 times 50 divide by 1000. So we have this will give us 0.25 kilowatts plus this will give us 0.4 kilowatts. So the power here is given to be 0.25 plus 0.4, that is 0.65 kilowatts. We are done with the power. So we are going to calculate the energy. So the energy is given to be power in kilowatts times time in hour. So by correct substitution, we have our power as 0.65 kilowatts times the time in 10R. 10R. So if you do that correctly, we have 0.65 times 10. That will give us 6 points. This is something as 6.5 kilowatts hour. That is our energy. And the standard unit in calculating electrical energy, that is it, 1 kilowatt hour. So our energy is 6.5 kilowatts hour. So the next thing to do is to calculate the cost. So the cost of electricity is going to be the rate of the electricity times the energy. Good. And by correct substitution, our rate is given at 20 kobo. 20 kobo per kilowatt hour times energy. Energy is given to be 6.5 kilowatt hour. As usual, this will cancel out this. What you're left with, we have 20 times 6.5. That will give us 130 kobo. Let me verify that again. 20 times 6.5. That will give us 130 kobo. Therefore, the cost of running those lamps with those different power rating in that apartment for 10 hours is given as 130 kobo. And that is the answer. So we have 130 kobo as our answer. We are done with this. The last but not the least, we want to look at question number 4. I want to believe I am very, very correct with my calculations. Oh. It was written 2 kobo, I wrote 20 kobo here. Yes. It was 2 kobo, I wrote 20 kobo. So if I clean this, we're going to have 2 times 6.5. And that will give us 13 kobo. So we'll clean this, and that becomes 13 kobo. That was the mix-up. I was wondering why my answer was different. So that is 13 kobo. So the next thing we are doing is question number 4, and then we call it a day. Question number 4 reads: a man has 5 60-watt bulbs and a 240-watt water heater in his apartment. If the bulbs and the water heater are switched on for 4 hours daily and the cost of electricity is 1.20 per kilowatt hour, calculate his bills for 30 days. I love this question. So let's collect our data. So we have our power P. Now total power P to be equals to 5 of these times 60 watts divide by 1000. I'm going to have 5 we're gonna have 0.3 kilowatts. So that is our power, 0.3 kilowatts. Good. So the next thing we want to look at, sorry, that is not it. We also have another power there, 240. So the total power, the total power becomes 0.3 kilowatts plus 240 by 1000. 240 watts by 1000 watts, and that will give us 0.3 kilowatts plus 0.24 kilowatts. So the total power in that question is 0.3 plus 0.2, that is 0.6. 0.3 plus 0.24, that is 0.54 kilowatts. That is the total power in the question. So the time T is switched on for 4 hours daily. Time is 4 hours daily. 4 hours per day. 4 hours daily. And the cost of the electricity is that, and it is switched for 30 days. So 4 hours daily times 30, so we have times 30 days, sometimes 30 days. So day we cancel day, you have 120 hours. That is the time we are going to use. I told us you must convert your time to hours. In years, in time, in seconds, in minutes, in whatever, you must convert the time to hours. That is the time T. So the cost, the rate now, the rate is given to be 1 naira 2 kobo. 1 naira 2 kobo per kilowatt hour. So we want to find the cost. So we have, in finding the cost, we must first find our energy. So our energy is going to be power times the time. So by correct substitution, our total power is 0.54 kilowatts. The time is 120 hours. So we have 0.54 times 120. That will give us 64.8. The energy becomes kilowatts hour. 64.8 kilowatt hour. So therefore our energy is given to be 64.8 kilowatt hour. So our cost of electricity now becomes rate times energy. Rate times energy. And if you do that correctly, our rate is 1 naira 2 kobo per kilowatt hour times energy. Energy is 64.8 kilowatt hour. This kilowatt hour will go with this kilowatt hour. And what do you have? You have 1.2 times 64.8. And that will give us 77 naira 76 kobo. That is the answer. So this, we have the cost is 77 naira, 77 naira 76 kobo. So we are done with this. In summary, in calculating the cost of electrical energy, you must master all Ohm's law equations. The work done in moving a positive charge from one point to another, all the equations in Ohm's law, you must master them. Number two, you must convert your time to hours. The time will be in year, in second, in minutes, in months. You must convert it to hours. Number three, your power must be in kilowatts. You convert any power given to you to kilowatt by dividing that power in watts by 1000. Number three, your energy must be in the unit of kilowatt-hour, not in joules. Your energy must be the unit of kilowatt-hour, not in joules, and this is the equation. Power in kilowatts, time in hour, and when you multiply them, you have kilowatt-hour. These are the standard units in calculating electric tariff in any part of the world. And then lastly, you are going to apply this universal equation. Cost of electricity is equal to the rate times the energy. This rate varies from country to country. In Nigeria, our currency is naira and kobo. In any part of the world you find yourself, you put your rate in this place and then you get your cost calculated. To this, we have come to the end of this video and this class. Don't forget to subscribe, like, comment, and share. Share this video to those that need it. God bless you. Bye-bye.